Okay, I will show you how to do problem 3 step by step until I finish the entire problem. So the first thing I hope you are not confused is that there are only one green dot, one blue dot, and one red dot. This is the trajectory, so this is how the green dot moves in a period of time from 0 to 2 seconds. There's only one green dot, and I'm just drawing out the green dot at multiple times so that you can see how it moves. It is from t equals, so I showed the position of the dots when t is 0, 0.1, 0.4, blah blah blah. So if you don't know which one is 0, which one is zero point 0.4, you can look at the function where the green dot at t equals 0, x green at t equals 0 should be 10 minus 7.5 times the time you plug in, which is 0. So it should be at 10, and it is in unit of meters. So this is exactly the unit we're using here. 5 grids represent 5 meters, so one small square here is a meter and a meter. So if initially x green is at positive 10, we know the green dots start moving from here. And if I look at x blue at t equals 0 is 12 minus 10 times 0, so it's going to be positive 12, which should also be positive 12 here. So you know that at t equals 0, this is where the blue and the green dot is, and the red dot is always at here. So if I just draw out what the state looks like, what the distance between the dots at t equals 0 look like, let me draw out t equals 0. Here's the x-axis. This is the y-axis. Let me draw it like this. And let me draw a x-axis in meters. When you draw a graph, always make sure to represent a symbol and the unit. Sometimes you don't need the unit because you're not plugging actual numbers, but if you are doing something that represent actual numbers, like here 10 is 10 meter, then you should indicate the unit of the graph. And usually just draw one arrow so you know that that direction is the positive direction. I saw a lot of people drawing two arrows, and I know it's probably how they told you, but I will suggest you just draw one arrow to represent which direction does x increase positively and which direction does y increase positively. Good. So at t equals 0, here's a green dot. It is at x equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the x position of the green dot at t equals 0 is 10, and y is 0. It is on the x-axis. It is on the horizontal axis. So at t equals 0, the green dot is at 12. It is at 10, 0. And if we look at the red dot, it is at the center. So it is at the center, and it's at the origin. So it is where the red dot is. For the blue dot, we can again count. Here is 5, here is another 5. So we have 5, 10, 11, 12. The blue dot has x position 12 at t equals 0. This is t equals 0. This is where the blue dot is at t equals 0. And if you look at the y position, it goes down by 1, 2, 3, 4, 5. So it is negative 5 because it is at the negative part of the y-axis. So it's 12, 5, 12 is a little bit far here. 12. This is not blue enough. 12. 5. And -5. Okay, so this is what the distance and relative position between the dots look like when t equals 0. Now, after time has passed for 0.1 second, t is now 0.1 second, then the dots has moved to green dot over here. This is when t equals 0.1, and blue dot over here. So if we look at the blue dot, it is at, again, 5, 10, 11. X is 11, and the Y is still -5. So I can go ahead and draw out the thing when t equals 0.1. It is going to be a little bit to the left, which is 11 and -5. Now, for the green dot, it is not on the grid line, so let's just say, so it is a little bit to the right of this line. That's minus like 0.2 from it. Let's say at x, okay, so it is 5, 6, 7, 8, 9, and a little bit. Let's say that a little bit is 0.2, so 8.2, and the y position is, it looks like it is on this line, so the y position is 1. So when t equals 0.1, the green dot is at, again, it is closer to the red dot compared to blue dot because it is at 8.2 and then 1. So this is what the thing looks like at t equals 0.1. Let's do the thing again. For next one is t equals 0.4. So for 0.4, blue dot becomes here, and the green dot moves to here. The blue dot is again 5, 6, 7, 8. It is at 8 and -5. So the blue dot at t equals 0.4 move to, it is 8 and -5. So it moved to 8 and -5. Now for the green dot. For the green dot, the x is, it looks like is 5, 6, 7, right on 7. And for the y position, it goes 1, 2, 3, and a little bit, let's call it 0.1. So 3.1 for the y and 7 for the x. It is still to the left of the blue dot, so let's draw it at here. This is 7 and 3.1. So you see, when I draw them time by time, it's hard to see what they are doing. That's why I draw out the trajectory. But if it is misleading, then I'm sorry. I hope I make it clear of what all this thing is doing now. There's always just 3 dots, but because they are moving, so their position will not stay the same, and they will go through this path, and this is the trajectory. All right, next one is t equals 0.5, so it's going to be this one. When t becomes 0.5, the dot comes to here. let's again do the blue one. 5, 6, 7. It is 7 and -5. Boom. So this is at t equals 0.5. It is at 7, -5. And for a green dot, it is at 1, 2, 3, 4, 5, 6, and a little bit. Is quite a little bit, so let's give it like 0.3. So 6.3 in the x and 3, almost 4. So let's do 3.8. So it's 6.3, 6.3 is 3.8. It is still closer to the red dot compared to the blue dot horizontally. So 6338. And if you really want to get the precise number, you can plug that time into the equation here and then you'll get a precise number, but it's not necessary for what? It's not necessary, but so that's not for this problem. Alright, so this, because this problem only asks you to sketch it, so even you calculate it like accurately, your sketch is not going to be, your hand is not going to be that accurate, so just estimate is enough. Alright, so next, have we done 0.5? Yes, we have done 0.5. By the way, the red dot stays at 0, so I don't need to draw it, I don't need to check the position all the time, it's just 0 in the red dot frame. Only when it is in the red dot frame, or I mean right now I know it is 0, so when we go to other frame we need to do the thing again. I'll show you later. So now let's do 0.9. So next one should be here. This is where the green dot is at 0.9, and 2, 3, 4, 5. This is where the blue dot is at t equals 0.9. So the blue dot is just 3 away from the y-axis, and again -5 down here. So at t equals 0.9, the blue dot will be at 3 and -5, which should be closer. And for the green dot, it seems like it is very close to the line over here. So let's say but we can see this one is closer, this is right on the line, this is a little bit lower, so let's give it like 1, 2, 3, 4 and 0.9. So let's go 4.9 for the y position. For the x, it is 1, 2, 3 and a little more, let's go 3.2. So for the green dot, it should be at this position when t equals 0.9, and 3.2 is to the right of the blue dot. We see that right now the blue dot has win the race in terms of changing x position. It goes from to the right of the green dot to the left of the green dot. Alright, let's draw out. Next one is t equals 1. So when t equals 1, the blue dot is at here. For t equals 1, t is time, by the way, time is passing, that's why they are moving their position in the red dot frame. And the green one is at here. So again, blue dot is 1, 2, -5. When t equals 1. Yeah. Put it there. Copy this thing. and I know the blue dot should move closer. And this is at t equals 1, if I remember correctly. Alright, for the green one, the green dot, t equals 1 give you 1, 2, 2 point something, and then 5. Let's call it 2.5. It looks like it's right in the middle, so yeah, 2.5 and then 5. So for the green dot at t equals 1, it is at 2.5 and 5 here. Next, we have 1.4. So at t equals 1.4, it is at here and here when t is 1.4. This is when t equals 1.4. So now the x position of the blue dot becomes negative. It is to the left of the y-axis, and it is -2. The horizontal one is still -5. So -2, -5 for t equals 1.4. So for t equals 1.4, by the way, I should include the unit of the time, so let me do that. These are kind of like important steps, so I don't want to just be sloppy. Okay, so do I remember where it is? It's not 2.5, it is -2, -5. Okay, so this is where the blue dot is when t equals 1.4. 1.4, it should go to the other side, like this. And the green dot will be at also negative, but it is like 0.6, so minus 0.6 is on the left hand side. And 1, 2, 3, 4, 4 plus a little, let's go 4.2. So here we have our green dot when t equals 1.5, 1.4, 1.4. It is also at the left hand side of the y-axis. Alright, next one is 1.5, yeah. So we need to draw out when t equals 1.5, where the dots at. The red dot is still in the origin because it is the red dot's frame. The red dot will always be at the origin and the red dot's frame. That's the definition of red dot's frame. So I want to look at 1.5, which is here and here. Here's -3 and here's -5. So the blue dot moved to -3 and -5. Copy. That's where the blue dot is, over here. For the green dot, it is at, this is t equals 1.5. It is at -1 and a little bit. Let's go with -1.5. And then we have 1, 2, 3, 3 and almost 4. Let's go with 3.8. So we have -1.5 and 3.8, yes. Hey. So the green dot should be around here. Alright, next we have t equals 1.9. So t equals 1.9 is here and here. The blue dot is at 5, 6, 7, -7, and -5, and the green dot is -4 and a little bit, so let's go with -4.1, and almost 1, let's call it 0.9. So those are the position of the dots when t equals 1.9. Second, I forgot the second again. Second. Good. So t equals 1.9 seconds. This is -7, -5. And this is almost around the x-axis because it should be just 0.9 away from the horizontal axis. Good. Our final point is t equals 2, and when t equals 2, this arrives at 5, 6, 7, 8, -8, and -5. This is -5, and it is at y on the y-axis, so it's 0. So this is t equals 2 seconds. And the blue one is at -8, so I should move it a little bit to the side, and the green one should go on top of the x-axis. Alright, so this is the 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 time instant. These are the 10 separate states that this trajectory graph is trying to show. If you cannot just do those things on this graph, then the straightforward way is to draw them one by one. Yes, this is not a tricky question. This is literally just spending your time doing homework. So if you find this tedious, yes, it is, but it's homework, right? So now we can, if we want to do part A, we want the xt graph first. So for the xt graph in the red dots frame, we already have all the data because this is indeed the red dots frame. We just need to summarize it into a graph. To do that, it is easier if we start with a table. I need to indicate it is the red dots frame so I don't get confused with the blue dots frame later. A easier way is to write the table like this, y red, and we have the blue dot. Let's go with green dot first, and the y of green dot, the x of blue dot, and the y of blue dot. So in this way, I don't need to write t, x, and y all the time. I just need to write down the numbers, and I don't need to write the unit all the time because I have already indicated the unit. So t goes from 0, 0.1, 0.4, 0.5, 0.9, 1, 1.4, 1.5, 1.9, and 2. So the x of red and y is always 0, 0, 0, 0, because it's at the origin. So now I can already plot the xt graph for the red dot in the red dots frame. So I need to indicate what I'm plotting. I'm plotting time and t, and I'm plotting the x position of the red dot, unit of meter. The unit doesn't really matter because it's going to be on on the x-axis because it's always 0. I have a point for this 0, and for point 1, this is point 1, and then I have it for point 4, point 5, point 9. Well, you know it's going to be always 0, so you can go ahead and just draw a horizontal line. Okay, so let's x red. That's the xt graph for the red dot in the red dot frame. The yt graph for the red dot is also very simple because it's also 0. So you can just copy paste this graph and replace it with y red. I don't prefer drawing on the same graph before x and y is different, even though they are both some length and in meter, but x and y are independent. They affect the motion different way. One is horizontal left and right, and one is up and down. So don't mix them. For the green dot, we have all the data. It is 10, 8.2, 7. Let's write it down first. 10, 8.2, 7. Alright, keep going. 6.3, 3.2. Alright, keep going. 2.5, 0.6, 2.5 minus 0.6, and we have 1.5. This is minus 1.5, and then for 1.5. Okay, so now we can plot the xt graph for the green dot. So I can use color to indicate I'm using the red dot. So I don't need to draw another exit again. But if you just want to draw another graph, that's totally fine. So let me go with 10. So let's say this is 10. So here is minus 10. And by sketching, I don't really need to be that accurate. So when it is 0, it is 10. When it is 0.1, 8.2. And when it goes to, let's go with the last one. So this is, I'm probably 0 to 2, so it should be 1 in the middle, and 0.5 in the middle, 1.5 in the middle. Let's do those 5 dots first. So at t equals 0.5, it is 6.3. So 6.3 is around here. Of course, you can try to graph it more accurately, but you don't have to for this problem. And at t equals 1, x green is 2.5. So it goes, so if there's 10, here is 5. So 2.5 is between 5 and 0. So it is here. And when t is 1.5, it's negative 1.5. Negative 1.5 should be closer than negative 5 to the horizontal axis. So let's say around here. And then for 2 is minus 5. So minus 5 is here. So you see it should be kind of like a straight line for the xt graph. So if you have a straight line, the let's do the vt graph later. Now let's do the yt graph for the green dot. So for the green dot, we just copy the y position instead of x position. 0 and 1. 0, 1. Let's do 2 positions at a time. Let's do 2 states at a time. And 3.1, 3.8, 3.1, 3.8. And 4.95, 4.95, 4.2, and 3.8. 4.2, 3.8, 0.9, and 0. 0.9 and 0. So if we plot the YT graph for the green dot, we should already see that it should go up and go down because it goes from 0. Let's indicate the, let's do 5 here. So it goes from 0 to, let's say here is again 2 seconds. So in the middle is 1, the middle is 0.5, middle is 1.5. It is 5 to it is 0 to 3.1 at 0.5. So 3.1 at 0.5 is 3 is around here. And then at 1 it goes to 5, so it goes to 5. At 0.5 it goes to 3.8, so 3.8, 3.8, 3.8, it should be at the same height. So let's go here, and then 2, 0. So it should go like this. If you want, yeah, so we know that the velocity for the y velocity for a green dot will not be a constant. There's no way. There's no way it's a constant. It doesn't look like a straight line at all. Let's go to the blue dot. So for the blue dot, we have 12. Actually, let me just do this. Copy, paste, and then copy, paste, and then copy, paste, cut, paste, and then cut, paste. If you have a lot of piece of paper, it should be easier for you because you can just look through your papers. I only have one screen, so sometimes there's good part of using physical papers. Yeah. Okay, I have all the exit. Oh, not all the. I still have more here and here. Okay. So now the x position of the blue dot goes from 12, 11, 8, 7, 3, 2, -2, -3, -7, -8. And for the y position, need to add more. It's always -5. Yay! I don't need to take time to remember it. It's always -5. -5, -5, -5, 5, 5, yeah. Okay. So now I'm ready to plot the xt graph and yt graph for the blue dot. For the blue dot, I use color blue, and yt graph looks easy because it's always -5. So let's just draw it -5. So it's always -5 for the blue dot. For the y position of the blue dot. Now for x position, it goes from when t equals 0 is 12. So I should go higher. So this is 15. Equally spacing in terms of 5. So 12 is somewhere around here, and then it goes at 0.5, it becomes 7. 7 is around here, and then at 1, it goes to blue dot, 2, 2, okay, 2, and then at 1.5 is -3, it should be -3, and at 2 it is -8, 2 is -8, so it is kind of like a straight line. I'll bet it's a straight line. So yeah, that's for the blue dot. Now I finished the xt graph and yt graph. The Vx meter per second graph is just the slope of the xt graph. So let me look at the xt graph for all my stuff. I can easily tell that for the red dot, the slope must be 0 because it is always 0. So for the red dot, I got a 0. For the green dot, it goes from 10 to 2. So it is, it goes from 10 to, this is, what am I drawing? I am drawing -5. So 10 to -5, this part is 15 but going down, and this is 2. So 15 divided by 2, I get 7.5. So that is negative because the x position decreases. It goes to the negative side. So I know for the green dot, the x velocity is -7.5 meters per second, and it looks like constant velocity, so I'll just draw a straight line. Now, for the blue one, I'll also assume it's a constant velocity, x velocity. It is 2, and it goes from 12 to -8, so it's 20 of change. So the slope will be -10 meters per second. Let's go down here. So this is for the blue dot. Let me erase this. So now I finished all the VXT graph for all the dots in the red dot frame. Let's go to YT graph. So for the y position of the red dot is not changing, it's a flat straight line, so the slope is 0. Same for the blue dot. I can just draw 0 for the red one and the blue one. And I need to make sure I can show that they are two different lines. Alright, that's close enough. Or I can move it. Yeah. Just make it fat, so you can see that there's a blue line, and you can see that there's a red line, and they're both 0. Okay. Now, the only thing with non-zero y velocity is the green dot. It's changing. I can just be lazy and indicate that this is so if I use these two dots, I don't really know if the velocity corresponds to 0, 0.5, 0.1, 0.2, something like that. So it seems like these two dots is too far away from each other. The delta t is too big. So we have 0.1, which is at 1. So 0.1 is at 1. And we have more dots. So let's focus on this part. Hey, hey. We just want the y position of the green dot. Okay. Now, I want to compute the y velocity, which is the y position at some later time minus the y position at original time divided by delta t. So it seems like my delta t is going to be 0.1 and another 0.1, another 0.1, another 0.1, another 0.1. So I'm going to get 1, 2, 3, 4, 5. I'm going to get 5 dots for my y velocity. So let's do that. And divide by s. So the y at later time is 1. So here the later time is the y at later time is 1 meter. The original y is 0. Subtract then divide by delta t, which is 0.1, give me 10. So that can correspond to, you can say correspond to t equals 0 or 0.1. It doesn't really matter because 0 and 0.1 is pretty close. It wouldn't matter where you draw the point. So I'll say, let's say this is for t0. So now in the white graph, I can say for 10, the blue dot has the velocity at, for t equals 0, the green dot has the y velocity of 10. Let's say, let's copy the thing again, just to make sure we are clear of what we're drawing. All right, next dot. The later one now will becomes the one at 0.5, which is 3.8. And subtract with the earlier one, 3.1 divided by 0.1, that is 7. So I got 7. This is 5, so I need to go, so 0, and then that is at time 0.4, sure. So again, 2, 1, 0.5, 1.5. So at 0.4, I have something that is like 7. And then at 0.9 to 1, I have the later time is, the later y position is 5, earlier is 4.9. So 5 minus 4.9, 0.1, that is 1. So I get 1 at 0.9, and then I get 3.8 for later time. See, now the later y position is smaller than the earlier y position. So when I calculate the y velocity, I should get a negative value. This is negative 4. So now the y velocity goes to negative 4. This is negative 5. Just in case, let me draw negative 10. So negative 4 should be up a little bit to the top. The last dot will be later time is 0, earlier time is 0.9. So I have later y position is 0 and earlier y position is 0.9. The later time is 2, the earlier time is 1.9. So the later y position is 0, the earlier is 0.9. Divided by 0.1, you get minus 9. So the y velocity becomes minus 9. So you see, it looks like a straight line. So that's the VYT graph for the green dot. And all of this completed problem part A. Yep. This is a tedious homework, but it's not hard. It just takes a lot of time. Oh, no, I finished both A and B. Good. So I finished both A and B. It's not that tedious. Good job. Now the problem is how to go to the trajectory in the blue dot frame. So let's just look at t equals 0. When t equals 0, where will the blue dot think that the other dots are at? So let's draw out the blue dot frame. The blue dot frame, by definition, should have the blue dot always at the center. So when t equals 0, the blue dot frame should be at here. It should be at here. So you can see right now, blue dot is at the origin of the blue dot frame. So in the blue dot frame, the green dot is 1, 2, 3, 4, 5. I know it's 5 because 0 is 5 above -5. So the green dot is 5 above the horizontal axis, and it should be from 12 to 10 is just 2. So it's going to be 2. And therefore, in the blue dot frame, you need to go left by 2, up by 5. So the green dot in the blue dot frame, when t equals 0, is -2 and 5. So that's how I get the position of the green dot in the blue dot frame at t equals 0. Good. So that's how I get the position of the green dot in the blue dot frame at t equals 0. All right. Let's look at the red dot. The red dot is, I know this should be 12 because blue dot is at 12. So the red dot is 12 grid horizontally from the blue dot. And it should be 5 vertically from the blue dot. So it will be at negative 12, 5 on the blue dot frame. So now I get it. I get the first t, I guess for t equals 0, the position of red dot and green dot in the blue dot frame. Let's do the same thing for other time. When t equals 0.1, here's where the blue dot frame is. You will see that the blue dot frame is moving in the red dot frame because blue dot is moving and the blue dot frame must move with the blue dot in order to keep the blue dot at the origin. That's the definition of the blue dot frame. It is how the blue dot see the world, and the blue dot frame always move with blue dot. So now, I don't know why we have 12 point, oh, because I was copy pasting the stuff. Oops, let's go back and see which one is the correct one. At t equals 0.4, the blue dot should be at 8. Yeah, this is the correct one. I guess the lowest one is the correct one. Hey, hey, hey. Okay, good. So now let's look at green dot again. 8.2 is it should be 11 minus 8.2. 2.8 to the left of the blue dot. So in the blue dot frame, the green dot is right now 2.8 to the left, and for the y position, it goes 1, 2, 3, 4 until 5 minus 5 to 1 is 6. The distance vertically is 6, so it is at 2.5 and 6. Now, for the red dot, it is going to be 11 because I know the red dot is at 0, and this is 11, so it's 11, and this is 5, so it should be at 11, 5. Good, now we have t equals 0.1 down. Next is here, so the green dot should be 8 to 7 is just 1, minus 5 to 3.1 is 8.1, so I know in the blue dot's frame, oh, I think I missed a parenthesis. Okay, so in the blue dot's frame, the green dot at t equals 0.4 should be up here, and it should be minus 1 and 8.1. And for the red dot, it is going to be, that's right, 8 and 5. So it's going to be here. Minus 8 and 5 because the red dot is to the left of the blue dot. Good. Next we have here. We have 7 to 6.3 is 0.7. Minus 5 to 3.8 is 8.8. So you have the green dot at negative 0.7 because green dot is again to the left of the blue dot, and 8.8. And the red dot is 7 and 5, so it is at minus 7 and 5. Good. Next we have here, oh, very close. They are, oh, now the green dot has passed to the right hand side of the blue dot. So the green dot will be, let me make it clear by standing here. So you see the green dot is to the right of the blue dot. So it is 0.2, and horizontally it is 9.9. So now when t becomes 0.9, which is 0.9 seconds after everything starts moving, or after you start looking at their motion, the green dot moves to the right hand side of the blue dot. It is 0.2 and 9.9. And the red dot is still 5 above the blue, and now it's 3 to the left. So it is still to the left of the blue dot. Negative 3 and 5. Next we have here. So it is from 2 to 2.5, which means the distance here is 0.5. And vertically, it is 5 to, is this negative 5? It should be negative 5, yeah. So 5 to negative 5 is 10. We have the green dot in the blue dot's frame at 0.5 and 10. 0.5 and 10. Here. And 10. Okay, Now for the red dot it's 2 and 5. So it will be 2 and 5, minus 2 and 5. Okay, good. Now we have t equals 1.4 over here. So now both of them is at the right hand side of the blue dot. Plot twist, yay. So minus 0.6 to minus 2, this is 1.4, and the y displacement is 9.2. So I can have it should be 1.4 to the right, 9.2 to the top. And here's where the green dot is in the blue dot's frame at 1.4 second. For the red dot, it's going to be just 2 and 5. So the red dot is going to be 2 and 5 here. 2 and 5. Good. And for t equals 1.5, here, this is in the way. Let me move it away. Okay, so the green dot is 1.5 to the right and 8.8. So in the blue dot's frame, the green dot is 1.5, 8.8, and the red dot is 3 and 5. Oh, so I didn't draw it on the correct scale, but that's fine because I wrote down the numbers. So as long as I have the correct numbers, I can for sure keep moving. Good. Now, the next one will be, let me draw a blue dot here. Okay, the next one will be t equals 1.9. This is again in a way. Let me move it to the other side. All right. Hey, all right. So it is -7 to 4.1. That is 2.9. 2.9, and then this is -5 to 0.9. This is 5.9. So we have the exit over here, and the green one is at 2.9 and 5.9. The red one is at, so here we have a distance of 7 horizontally, 5 vertically. So it will be over here, 7, 5. Now our last one. If you just want to get the final answer, you know that you don't really need to do so many detail, but now I'm teaching, so let me just do all the thing. So for t equals 2, -8 to 5 is 3, and here is again 5. So the green dot is at 3, 5. And for the red dot is at 8, 5. So it will be at here. Good. So now we know at every state where the position of the green and red dot will be in the blue dot's frame. So for D and E, we just need to do the same thing again for A and B. So let me again summarize everything into a table, but in the blue dot's frame. And now I kind of know for the positions, I don't really need all the time because they are going to look straight anyway. If you are not sure, just go ahead and do all the time and then you'll see. So let me just do 0, 0.5, 1, 1.5, and 2. So the blue one will always be 0 because it is the blue dot's frame. And let's look at those at let's look at the red one, the red dot first. So red dot is I just need the 0.5 one. So let's go to 0. At 0 is 12 and 5, and then at 0.5 it is -7 and 5, and then we have 1, which is here, and then we have 1.5, which is at here, and then finally at 2 we have it at here. Good. So now we have -12, -7, -2, 3, and 8. 5, 5, 5, 5, 5. Okay, so that's for the red dot. Time for the green dot. Actually, let's do green dot separately because we know we will need more time for the y velocity of the green dot. So let's move them over here and give blue dot some space. Green dot. Let's give green dot some space. Green dot will need more detail. So 0, 0.1, 0.4, 0.5, 0.9, 1, 1.4. Okay, so for the green dot, we have initially is -2 and 5, and then here -1 and 8.1 when t is 0.4, and then when t is 0.5, and then when t is 0.9, and when t is 1, and t is 1.4, t is 1.5, (1.9), and finally 2. not here. Here, okay. So the X position of the green dot, let me just remove this a little for now because it's just 0. Okay, so for the green dot, it's going to be -2, 2.8, -1, -0.7, 0.2, 0.5, 1.4, 1.5, 2.9, 3, and for the y it's 5, 6, blah blah, 8, 8, 9, 9, 10, 9.2, 8.8, 5.9, and 5. Good. Let me put the zeros back just for consistency. Good. So now I'm for sure ready to plot all the plots. Let me just draw the exit again. Start with the xt plot. I already know by plotting in the red dot frame that we need t equals 0 to 2. So let's just go ahead and go by 0.5 second. This is x. So for the blue dot frame, the easiest one is the blue dot. It's just going to be 0 all the way. Same for the YT graph. The blue dot is at the origin, so the y position of the blue dot is always 0 at or in the blue dot frame. It will be different in other frames, like what we see for the red dot frame. But now in the blue dot frame, the blue dot is always at the origin. So again, let me just draw. I need 2 seconds totally. And here. So for the blue dot, this part is easy. Now for the red dot, it is going to be -12. Let's indicate that. Let's do 5 and 10 because it's easier to schedule it with equal spacing. So it starts with -12 and then -7, -2, 3, and 8. So it's again a straight line. For the y position is always the same, it's always at 5. So let me do 5 here, 10 here, and at 5 it will be a straight line. Good. Now for the green dot. At 0 it is x -2, -2, and 2.8, minus. I think I copied the wrong thing. At 0.1, t equals 0.1, t equals 0.1, it should be 2.8 and 6, which doesn't make sense. It should be negative 2.8 and 6. Good. So it should be negative 2.5 is too much. So it should be, I am using my brain, but if you have calculator, it should be easier for you. 2.8, huh? 11, 2.8, then initially it will be 2, 11, 8.2. Am I wrong? 10, 8.2, 7, 10. It should be 9.2. Yeah, it should be 9.2. Because I didn't plot this time for the XT plot in the red dot frame, so I didn't call that mistake at that time. But it's fine. The good thing about plotting is that you can easily spot your mistake, and it should be negative 1.8 here. Good. So it goes negative 1.8, negative 1, negative 0.7, 0.2. Oh, I'm looking at not that low. So minus 2 and minus 0.7. So this should be minus 0.7, almost on the line. And then 0.5, 1.4, and 3. So it's also a straight line, but the slope is smaller. Good. So for the y, it is 5, and this is green. 5, 6. I'm looking at, all right, 8.8, 10, 8.8, and 5. So it should be a curve. So again, the velocity is not a constant. Let me plot the x velocity first. It is easier. They are all just constant. And you can see that now the x position is increasing. So the direction of x velocity is different for the green dot in the blue dot's frame. It is because when they are all moving to the left, the blue dot is moving faster toward the left. So the blue dot will pass the green dot. So relative to the blue dot, the green dot should be moving to the right. So that's why we see that in the blue dot's frame, the blue dot is moving to the right. All right, so we have the slope is in 2 seconds. I change my x position for the green dot is from negative 2 to 3, so that is 5. So it becomes 5 divided by 2 is 2.5. So I can draw, let's say 5 is here, and 2.5 will be here, and the green dot will have velocity like this. For the red dot, the time that had passed is also 2 seconds, and the amount of change of x position is from minus 12 to 8, so that's 20. So you have 10. Oh, all right, let's say this is 10, this is 5, so 2.5 will be down here, and 10 will be up there. Good. And for the blue dot, guess what? It's just 0 because it's not moving. It's always at the origin. Okay, so we finished the xt plot and vt plot. For here, the vyt plot, let's start with the two easy one, which are both 0, because they are just flat lines. T and y, vy, it should be meter per second. So 2, 1, 0 for the blue dot and the red dot, because they are not changing their y position. And for the green dot, it is going to be, again, we need to do the calculation. Vy, this is the y velocity in the blue dot's frame for the green dot. So here the later time is, so I'm looking at y velocity, I don't need the x. I don't need the x. The later position is 6, the earlier is 5, divided by delta t, you get 10. Later is 8, earlier is 0.1, divided by delta t, you get 7. and later is 10, this is 99, delta t, get 1, later minus earlier, delta t, get 4, later minus earlier, divided by delta t, you get, oh, these two should be negative, yep, good. Okay, so 10, 7, 1, 94, 9. If you look at here, you'll see it is exactly the same, because the blue dot is moving horizontally in the x direction in the red dot's frame. So the x velocity they see will be different, but for the y direction, because the red and blue dot in the it's not moving relatively in the y direction, so you will end up seeing the same y position for the green dot. But in general, if two frames are moving, the velocity they see will be different. So I can just take whatever I have here and kaboom. This is also the same BYT graph for what we see in the blue dot frame. So position will be different in different frame, and velocity in general will be different in different frame, but that's not always so if you get the same y or x velocity in two different frames, don't be too afraid that your answer is wrong, because sometimes it will be correct. Like in this case, the blue and red dot are moving horizontally relative to each other, so the vertical thing will be the same. Alright, that's it.